do this activity outside, and I'm going to have you guys try to do this outside and see what you can get to happen. Or even if you're near a window and sunlight's coming in. I'm just not happening to be near a window where sunlight can come in easily. That isn't directly overhead. So you should have a solar panel in your kit. It might be a big one. You might have a couple of small ones. And if you have two small ones, you might have to wire them together. And you can either use a terminal block or any other, just twisting the wires together. And you can test out your voltage that you're going to get with your solar panel. And so right now I've got mine hooked into a little fan, right? It's not generating a lot of current because I'm indoors, so I don't have a lot of light. And when I switch on my multimeter to my voltage to 20, right, I'm gonna get a little bit of volts. So I'm gonna clamp it so I'll be able to hold it better. Okay, so it looks like I'm getting about 2.7 volts. And now what you can do is, since I'm indoors, I can raise my solar panel up closer to my light source, and you'll see that my reading keeps going up, all right, as I get closer and closer to my light source. This is a phenomenon known as the 1 over r squared law. As you get closer to a light source, it gets more intense. Or another way to think about it is that as you get further away from a light source, it spreads out in the shape of a circle, and the area of a circle, right, it's pi r squared. So 2 to 4 feet is actually a difference from 4 to 16, right? So it's 4 times less intense, right, when you're from 2 to 4 feet away, right? So because it's that 1 over r squared drop off. That's why flashlights don't go forever. The energy spreads out pretty quickly, and it just gets diffused. Okay. Now what you're also going to do outdoors is you'll soon see that as you have your solar panel and you tilt it up at an angle, you're going to see our numbers start to go down, okay, based upon the angle at which you're holding your solar panel. Because as you bring up the angle, you're reducing the surface area of the solar panel that sees the light source. Think of this as the same way with the seasons, right? When we looked at how much energy that gets lit up in Ontario versus how much energy gets lit up same area in Texas, right? The angle of the earth causes the light beam from the sun to get spread out more in Ontario versus Texas. So the same amount of energy is having to cover a larger area in Ontario. That's why it's colder there, right? And that's why it's warmer in Texas. And so this is why when you're driving down the Mass Pike or in other places where you see where they've got their solar panels, they're always at an angle and they will always be facing south. Because here in Massachusetts, because we're far enough north, the sun will always be in the southern part of the sky, so the solar panels will always be facing the south in that direction. Now, notice I had my solar panel hooked up to my fan earlier, and it sure wasn't coming on, because I was not generating a very large current. So this is why it's very difficult to beat the sun. Because the sun has a lot of energy, and it has a lot of energy across the spectrum. Okay, so notice I've got my solar panel hooked right into my fan, and since we do hydroponic, I happen to have a hydroponic light. And so now let's get this guy nice and bright, and my fan starts to turn. Okay, because I generated enough current, and as I move my light away, right, my fan stops. I get it closer. You can start to see it starting to turn. There it goes. Right, I'm generating enough current again for my fan to come on. So what you're going to do outdoors is test out the angle. You also can test out how much of my solar panel do I need to cover to generate enough current, right, to keep your fan on. Okay, and you can also, when you're in the sunlight, since you do have a couple of fans, how many fans can you power? And can you power even an LED light with your solar panel? And one of the things that we'll also do is, it's a little harder to do indoors. But again, you have your cellophane. You're going to learn about the electromagnetic spectrum as part of the reading. And we know that visible light goes from bluish to reddish. Blue is more high energy. Red is lower energy. This means that when blue light hits the solar panel, it's going to knock more of the electrons loose, and you're going to get a bigger current than if it was red. So if I hold a red cellophane paper over my solar panel, it's likely to work a lot worse than when I don't have that there, because the red is only letting the red photons through, okay, or the red part of the spectrum. Whereas if I've got a yellow one, it's going to let through the yellow frequency, which is kind of the middle. So your fan might still come on when you're outdoors. Kind of depends on how much light is getting absorbed and how sunny it is, and whether you're in direct sunlight and things like that. So what I want you to do is to test out the different cellophanes, test out the different angles, and see, what's the conditions under which the fan comes on.